Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement. A square pyramid, 35 sides of base and 60 axis length, rests on HP on one of its slant edges. Draw the projection of the pyramid when the axis appears to be inclined to VP at 45 degrees. So here we need to observe certain things. That is, the first condition, that is the initial resting condition, is not given to us, whether it is resting on its corner or one of its edges. But however, a clue is given in the problem statement that it is resting on HP on one of its slant edges. So in the previous problems, we had seen where the axis was inclined to the HP, but here on the HP, it is resting on one of its slant edges. So we need to understand that a pyramid can be resting on its slant edges only when it is resting on one of its corner. That is how the rotation can be done. So if it is resting on one of its slant triangular faces, then the pyramid has to rest on one of its edges, but here it is resting on one of its slant edges on the HP, and hence the initial condition will be it is resting on one of its corner. And also with respect to the VP, he tells that it appears to be inclined to VP at an angle of 45 degrees, which very clearly mentions that the given angle itself is the beta angle. So now let us see how the solution for this problem statement can be drafted. So first let us begin by drawing a line of any arbitrary length of thickness 0.18 and then annotating this line as x and y, and also the reference planes as VP and HP. Let us try to draw the top view of the square pyramid resting on one of its corner. So first let us draw a square of 35 edge length. Now let us select this square and give a rotation in such a way that it is resting on one of its corners. So for that, select the two extreme points on a diagonal and ensure that that particular diagonal is being parallel to the xy line. So this completes the position of the square pyramid resting on one of its corners. So now let us draw the triangular faces by joining the diagonals. So let us annotate. So this is the corner A, corner B, corner C, and corner D. So these are the four corners, and then O is the apex of the pyramid, and here this is O1, which is the center point of the bottom face of the pyramid. So this point is O1. So now let us draw the front view of the square pyramid. So for that, let us select a line of thickness 0.13 and draw the projection lines to intersect the XY line from each of the corners of the square pyramid. So from the points of intersection, draw the front view, which is going to mark the bottom plate of the square pyramid. And now let us draw the axis of length 60 and then join it to the two extreme corners. And those corners are A dash and C dash. Also, this is the apex of the pyramid. And here, this is the corner B dash, which is visible first, followed by the corner D dash. And next, this is the axis point, that is O dash, which is originating from the bottom face of the pyramid. So this is O1 dash. So next we have got the next condition, that is it is resting on one of its slant edges. So now we are going to rotate this particular front view of the pyramid in such a way that on the HP it is resting on one of its slant edges, that is O dash A dash. So for that, let us select the pyramid front view and make this a rigid set. Next, let us reselect the pyramid along with the annotations, and then try to move the pyramid first by creating a copy of it. So let us keep the point A dash as fixed point, and then let us rotate this. So here the apex was not selected, so let us annotate this O dash. So now let us select this pyramid along with the annotations and the edges. So now we are going to rotate such a way that it is to rest on one of its slant edges, that is O dash A dash. So ensure the copy is off. So now let us select the point, that is A dash and O dash, and just ensure that it is being tilted in such a way that it is resting completely on the XY line. So you can just observe that the XY line is turning red, and this marks the resting of the pyramid on its slant edge, that is O dash A dash. So just select the move option, ensure the copy is off, and drag it to a convenient distance so that there is sufficient place to complete the third view of the pyramid. So now the front view is done. Let us depict the top view by drawing the vertical projection lines from each of the corners. So from corner A, it has to reach the projection of the O dash. Similarly, from corner B, intersect the projection line of the corner B. Ensure all the horizontal projection lines are making an angle of 0 degrees or 180 degrees. And this is the corner D. So now for the observer, the farthest corner point will be the corner A. So all the lines originating from this particular corner meeting the apex will be the dotted line. So let us select the line option. Select the line of thickness 0.50 mm. Let it be a dotted line. So the point A is going to lie here. So from this point of intersection to the apex, it is going to be a dotted line. Rest all will be the thick lines. So let us complete the bottom portion of the pyramid, followed by joining all the corners to the apex. So the hidden line is overlapped. Next, use the trim option. So trim the projection lines which is not required for us. And here this is also the axis line. So let us just ensure that this line is drawn as two different lines so that we get the axis point separately. So this projection line has to extend till here because here lies the point B. So now let us annotate this. So this is the apex O. This is the corner B, corner A, and corner C, corner D. And this is the center, that is O1. So now let us select this top view of the pyramid, make this a rigid set. So the pyramid is rigid now. So now the given angle itself is the beta angle because it is very clearly told that it appears to be 45 degrees. So next, let us draw a line which is inclined at an angle of 45 degrees to the vertical plane. So the angle is minus 180 plus 45. So you can use the angle between. So it is 45 degrees. So the only difference here is the initial resting condition is not given, but however, the resting condition on the HP is clearly mentioned. That is, it is resting on one of its slant edges. That is O dash and A dash. Okay. So now we will select this pyramid along with the axis and then try to position this pyramid in such a way that its axis is inclined to the vertical plane at an angle of 45 degrees. So let us select a line of thickness 0.13 and draw the horizontal projection lines. So from corner C and also from corner B and D, the corner A is on the XY line. Now let us draw the vertical projections. So the point O is also on the XY line. Similarly, from A, intersect the XY line. From B, intersect the projection from the corner B, and the vertical projection of corner C and vertical projection of corner D shall intersect the respective horizontal projection lines. And we can also draw the projection line from the point O1 to intersect the projection from O1 in the vertical plane. So now let us complete the front view by selecting the line of thickness 0.50 mm. So let us start from the corner A to corner B, B to corner C, C to D, and D to A, and also O and A, then B to O, and also C to O. So D is the farthest corner point, so it will be the hidden line. So from D to O, this will be the hidden line. So let us annotate the front view. So this is the corner C dash, corner D dash, and corner A dash. This is the corner B dash, and this is the apex O. So O dash, and next here is the point O1. So let us annotate this as O1 dash. So let us draw the axis line. Select the line option. Select a chain line of thickness 0.13 mm. So from O1 dash to the point O, this will be the axis of the pyramid. So you can just see that initially the pyramid is resting on one of its corner, and it is rotated in such a way that it is resting on one of its slant edges on the HP, and then it is inclined to VP such that it appears to be inclined at an angle of 45 degrees to the VP. So with this we complete the drafting of the solution for a given problem statement. Thank you all for watching.